Hi, my name is Monsellano and I'm going to do my chemistry exam. Okay, first I'm going to start with the ideal gas law, and my problem is the second one. So my problem says, calculate the pressure exerted by 92 grams of Xe in a confined in 4 liters containers where the gas is occupied at 3/5 of containers and the temperature is 68 Celsius. Okay, first here we need to know our formula of the ideal gas, and here is our formula. It's pressure plus volume is equal to moles plus R plus T. Okay, so then we always need to know that our moles always need to be in moles, not in grams. And here in our problem we have 92, it's a gram, so we need to pass it to moles. Okay, so we have a formula that it's mole equal to gas divided by atomic weight. And so here is our formula, that is mole equal to grams divided by atomic weight. Okay, atomic weight, we are going to use Xe, that is xenon, because our problem says that this one is the one that we need to use. Okay, so we have that mole is equal to 92 grams, that are the grams that we have in the problem, divided by 131. Why 131? Okay, because in the periodic table, Xe had the atomic weight as 131.293, and this number is closer to 131. Okay, so we put it like this. Okay, so we have already our moles, so we can do our data, our complete data. Almost our complete data. Okay, we have here that pressure, it's the number that we need to search. Volume, okay, in volume says that we have 4 liters, but it says that we occupied the 3/5. So what we need to do is to multiply, to divide 4 divided by 5 multiplied by 3, okay? And our number is about 2.4, okay? So our volume is gonna be about 2.4. Okay, 2.4 liters. Remember that always the volume goes in liters. Then we have R, that is equal to 0.082, and this number is always gonna be of R. Okay, it's a rule. And temperature, we have that it's 68 plus 273.5. Remember that always Celsius we need to pass to Kelvin to resolve our problems. So I'm gonna do this one. And our result is 341.50. Okay, so now we have all our data, and what we need to do is to leave alone P, because it's the one that we are searching for. And here volume, it's multiplying P, so this one will pass dividing, so it will be moles plus R plus T divided by volume. So let's gonna do that. So here is our formula already with P alone, and the thing that we need to do is to pass these ones or to put the corresponding numbers. So we have that mole, it's equal to 0.70, R it's equal to 0.082, and temperature it's equal to 341.50, divided by the volume, there it's 2.4, there it's equal to 8.15 atm, because always pressure it's about atm. Okay, so this is our first result. Okay, now we're going to go with Charles' law. Okay, my problem is the first one. Okay, a container holds 50,000 milliliters of nitrogen at 35 Celsius and pressure of 76 mmH. What will be its volume if a temperature increased by 50 Celsius? Okay, first we need to know our formula. Our formula is volume 1 divided by temperature 1 is equal to volume 2 divided by temperature 2. Okay, we remember that always our volume needs to be in liters, and here in this problem we have our volume in milliliters. Okay, so we need to pass to liters. And also here we have that our temperatures are in Celsius, so we need to pass to Kelvin. Okay, so now first we're going to put the 850 milliliters divided by 1000. Okay, and here it's our result that we have 0.85 liters, so we have our volume correct. Then we have volume 2, that is the volume that we're searching for. Then we have our temperature 1, that is about 335, that is our Celsius, plus 2073.50 because that's the we can pass to Kelvin, and that is equal to 308.15. Okay, so now here's the complicated or the tricky of this problem. The temperature 2 is saying us that a volume in the temperature increased by 50. Okay, by. So by it's the clue that it's telling us that it's 35 more 50. Okay, it's not only 50 and only 35. No, it's 35 and 35 more 15, that is 85. Okay, so we are going to put 85 more 2073.50 like this, because remember the clue here it's by. Okay, 50 it's not the final temperature, it's 35 more 50, that is 85. Okay, so we have that our result is about 358.12. Okay, so now here in the top we have the formula without the B2. So it's B2 here, so we need to leave it alone. The T2 here it's dividing, so it will pass and multiplying. So that's why V1 and V2 are here in the top multiplying, and here the T1 divided. Okay, so we put the corresponding numbers, that V1 it's equal to 0.85 plus multiplying to T2, that is equal to 358.12 divided by the temperature 1, that is 308.12, that it's equal to 0.98 liters. Okay, so this is our second result. And we finally go with molarity, that my problem is the third one. Well, the problem says how many milliliters of solution will result when 40 grams of H2SO4 is dissolved to make a O200 molarity solution. Okay, first our principal formula is this one. Molarity is equal to moles divided by liters, but here it's asking for milliliters, and here is giving us grams. Okay, the grams that are the moles, but we need to change from grams to moles, and we already have that formula, and we have already our molarity. Okay, so first we're going to pass the 42 moles. Okay, so here is our formula. So we can pass from grams to moles, that is gram divided by atomic weight, and here are the corresponding numbers, that is 40 because our problem is telling us that the grams that we have are 40, and then to have this number we need to do this one. Okay, so here says that are 40 grams of H2SO4. So we need to put here the times that the letter or the element repeats. Here in this case H repeats 2, S repeats any time, and O repeats 4. Okay, and these ones, that is 1, 32 and 16, are the atomic weight of each element. So we multiply these ones, and then with these results we get all together, and we have here that it's 98. So that's why here we have this number, and the result is 0.40. Okay, it's 0.40. So we have already our moles. So now we need to leave along this one, the L, because we want to know the milliliters, and we already have the molarity and the moles like this. And now this is with the corresponding numbers. Liters it's equal to moles, that it's about 0.40, that it's here, and we have here that our molarity it's equal to 200. So here we have these ones, and we need to divide it. the result of these two is about 2, okay? So now the problem is telling us that we need milliliters, no liters, okay? Because these two, it's about liters. So to pass from liters to milliliters, we need to multiply by 1000, okay? So we'll multiply 2 plus 1000, that is equal to 2000 milliliters. And this is our third and final result.